in response to the recent tragic events in Turkey, where the rescue efforts for the earthquake has been very difficult. We decided to use Qualcomm's state-of-the-art hardware development kit to create an application for survivors of natural disasters like earthquakes to send out distress signals.
Here we have an Android app developed using Kotlin. It's a combination of both the client side, in the case of those that need help, and the rescuers who are helping those in need. Let's start with one of the most important components on the app, which is the Google Map, which is powered by the Google Map API. This displays markers, which indicates victims which have sent distress signals to the rescuers. As a rescuer, a person can further inquire and see which of these victims have the most urgency of being rescued and how many people are nearby. For example, if I click here, I can see who has sent the distress signal, how urgent their request is, and this can be based on a number of factors like if they're hurt, how many people are nearby. Like over here, they indicated that there are 2 people nearby. This can help influence how the rescuers execute the operation and go through with the search and rescue mission. Now the question is, how does a user actually send a distress signal? Well, on the user interface, they would be given an add button like this shown over here, where they're given fields like name, urgency, and the people nearby. And once they input the information, the map will automatically detect their location and pinpoint it, as well as sending the location to the rescuers, which they will be notified of. Here the user has submitted the information. Once we click submit, the Snapdragon GPS system will track the user's location and indicate it on the map. Over here, it shows that we're in North York, which is in the vicinity of where we are right now. Moving on, I'd like to talk about another feature which we implemented. In distress times like these, a person may always need somebody to talk to, whether they're alone or with somebody, or maybe somebody to ask questions for to help themselves or somebody else who's in pain. So we integrated OpenAI's trained language models to assist people with their inquiries, while rescuers are helping devise their plan to rescue them. Over here, we can see that there's a chat application where a person can enter their inquiry. Over here, we have a sample inquiry from a user or a victim who's under rubble. And once the user clicks send, it sends a request to the backend application, which sends a request to the OpenAI model. And over here, you can see that it's a courteous reply, and it gives some information as well that for them to stay calm and that help is on the way. That was most of the client side features. Now we'll move on to more of the rescuer side features, and as you can see on the left, we have integrated an Arduino, but we'll talk more about that later. One of the other features implemented but more for the rescuer side is a camera AR detect feature. The idea for this came from the fact that during earthquakes, one of the biggest problems are firstly the loss of lives, and secondly the devastation in the environment due to buildings falling. And with that hinders the rescue operations. So using Snapdragon's state-of-the-art camera, we utilized the front-facing camera over here to take pictures of terrain, which rescuers can send back to the people who are working behind the scenes. Over here, we'll send a dummy photo where, now, as you can see, it's sent over immediately to the Dropbox repository in the cloud, and that way people can access it in the behind the scenes.
So the Arduino and breadboard circuitry component is a prototype design for a device that we developed to be used by the rescuers. And the rescuers are able to relay live data from the victim's vicinity, and this is achieved by using some of the actuators connected to the circuitry. So for example, on the rescuee side, I can press the buzzer on, and the buzzer would beep. Also, the microphone is an analog sensor that has the capability of detecting small noises near them to help locate the victim's whereabouts. Finally, a temperature and humidity gauge is used to help the rescuer find the most logical environment conditions where the victims are most likely to hide. Now we come to the most important component of the circuit. So to protect the HC05 Bluetooth module, we designed a circuit to work with a voltage divider using resistors. And this Bluetooth module communicates with the Snapdragon device.
We faced many challenges as we programmed the Android application. Kotlin is a new language to us, so we had to spend a lot of time reading documentations and understanding the implementations. Debugging was also challenging as we faced errors that we're not familiar with. Ultimately, we used online forums like Stack Overflow to guide us through the project. If we had more time, we can incorporate more sensors on our Arduino board to better aid the rescue mission. We can also display a travel route to the victims on our application.